All right. Well, the topic this week, I was thinking about this, and we had made mention of this. Gosh, it's been quite a few weeks back, and we were talking about somebody had asked a question about motor circuits and stuff, and I said I'll do a topic on that. So I'm going to do the motor branch circuit and feeder conductors, how to go about sizing them. It's very
Okay.
simple, but the last portion of the slides that I'm going to have, they're from the 2017 because they're updating all the illustrations that are in the motor section. But this is going to go in showing part winding motors and where you have periodic duty, intermediate duty, and all of that. You're using the duty cycles and all that. So I'm going to
Okay.
show quite a few different type of calculations here that people might have never seen. So
All
I
right.
just I decided to go through this and just sort of show everybody, and they're pretty basic. And the first one you're going to look at here is we're going to be looking at 430.22, and we're just going to be looking at doing single motors. And when you look at this, it tells you anytime you're doing a single motor, and it doesn't matter if it's for single phase or three phase, we're going to take it at what? 125%. Okay.
Yes, sir.
So here's your table for sizing the conductors. I actually have two of them to show two different types because I have it in two parts here. This is part one of table 310.16 that goes up to 4 aught, and we're going to be using the 75° C column when we do this. And then anything, if it was above 4 aught, here's your 250 up to 2000 KC mill. All right.
So the reason behind the 125% is that most motors are considered to run for more than 3 hours
Right.
at full load.
Right. And
Gotcha.
And when you look at this, I didn't even do the calculation here. I'll show some of them in the others, but I just wanted everybody to sort of get a look at what you're looking at when you go in and you start looking at sizing these conductors. So if you look at it and you see the panel board there, and then I'm going to the disconnect, and right there we show you the conductors, and it says 430.22. Now I I could take that disconnect. It means we're showing you that as time delay fuses. Now we
Right.
know just a little while back we touched base on this a few weeks back. Ryan come in and said that was a feeder. I'm
Right.
telling you that's not a feeder. Okay, that's
Well,
where you're sizing your branch circuit conductors over to it. All right,
yeah.
and
I mean, in that case, like, where is your final overcurrent device? I mean, that's kind of a weird way to look at it. I think, as far as interpretation goes, you know.
well, sure it
I
is
mean,
because you're feeding a single motor. A feeder is two or more motors or a motor and other loads. And we'll
right.
look at that when we get to 430.24.
Would that even get more complicated when you get into like the definition of like appliance with the combination of motor and other?
Well, the only
Uh,
difference is you're going to use a nameplate value. You're not going to use the table value.
oh, got you. Okay,
Okay. And
Tempor, got you.
yeah, and when you look at this, we put an exercise problem here for you to look at. And I'm not going to go through this because everybody knows how to size, you know, a single motor or two or more motors. And all you would do is we're looking at this and we have a 2 horsepower motor. It's single phase, 208 volts. All you're going to do, and I like to break this down so everybody knows where they're looking at. So when they're going through, listen to me teach this, they I want them to actually go back and look and try to work this problem on their own.
Right.
So if if you go and look at 240.4G, okay, when you go pick that heading up there, it says specific conductor applications. And then you
Yep.
go down and it's going to talk about motor control circuit conductors. And it's going to say, it'll say, see Article 430, and it's going to have all of these parts. Okay.
Right.
Well, then I also teach it this way. I say, whenever you get ready to start doing your your calculation, go look at 430.6A1 at the very front of Article 430, because right there it's going to talk about the heading in A1 is going to talk about table values. And basically, what it says is anytime you're calculating your conductors or overcurrent protection devices, you want to use the values that are given in tables 430.247 through 250. In this case, since we're doing a single phase, I'm going to look at table 430.248 to go get the amperage rating for that horsepower. So that would go in step one. So I just picked
Right.
the 208-volt column, come over 2 horsepower. I'm not going to tell the value. I'm going to let people do this one. And then you go down to step two, and 430.22 said to take it at what? 125%. Once
Yep.
you calculate that, there's your amperage. Then you go to table 310.16, and that's where you're going to go to the next size above that calculated amperage in the 75-degree C column, and it's going to tell you the size conductor. Okay?
Right.
Now,
Well, and one thing I was gonna say too, for all the people out there that doesn't know James and his material, if you're getting ready for like a journeyman exam or something, there's no anything better out there than this kind of content. I ran through James's stuff before, and it just gives you that confidence that you know what the right answer is. You're not missing a step. You're not missing a code loop. You're not missing anything in there. He makes sure and covers everything that you need to know to get the correct answer. So I really
yeah,
appreciated that about it.
well, I appreciate you saying that. And, the way those calculations have been designed has been through 30 plus years, 40 years of teaching, and the students asking certain questions. We may even add another step sometimes to make it even easier to understand. And that just comes from the people out there asking us certain questions. Now, this one is a three phase. Now, I want you to look, it's the same calculation. The only difference here is I'm using table 430.250 for 40 horsepower, three phase, 460-volt design B. So, and I'll just help just a little here. If I pick the 460 volts up, come over with 40 amps, it's going to tell you it's good at 52 amps. Okay.
Right.
That's how you can get it. Then I come down to step two, and what do I take it at? 125%. I did not
Right.
change the calculation. Once you get that amperage, then you go to table 310.16, and the next size above that amperage is going to be your size conductor. Okay.
Right.
So instead of me doing everything for everybody for once, I want everybody to sort of have a little bit of go look this up and see what I'm telling you. And you can look right here and you can see the sections that are in the table or in the illustration that we want you to look at. So 430.22 is my 125%. I size my
Right.
conductors, table 310.16. It's all there. Okay. Now,
Right.
one of the other cool things about this is when you're going through, it doesn't matter if it's through the publication or it's through the online course. Before you get to this illustration, you see those steps right there in the exercise problem. There's going to be an example problem before that that actually has the sections, tables, and everything in each one of the steps. The reason they're not
Right.
in this because we want you to get used to learning where to find that information when you get to this point. And what's really cool about this, once we get this ready, is you're actually going to be able to go online and like where that 40 horsepower is, all you do is go online, you click that blank right there, and you can fill in the value. So
Right.
if you're out on the job, you can do it. You can put your own values in to remember the step procedure you're going to use. You can also click those sections over there. It'll pull up the section so you can see exactly how we did that calculation and where we got those percentages from. So,
Right.
in a way, this is very helpful for the people out in the industry, just not prepping for a test, just an everyday on the job tool.
Yeah,
So,
and I agree with that. There was this was kind of a funny story. They we were arguing some stuff out on the job site, and I knew that I was right because I've done it for a while,
mhm,
and I just passed the fire alarm test. And I'll tell you, nothing's better than studying hard and actually knowing the right answer on a test. But just like James was saying, we go out on the job and everyone's like, no, 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 you're wrong, da 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 da, and they're just pie in the sky, arguing about some stuff. And I said, well, it's like this because of this. I don't really understand it as good as I probably should, but the way I understand it, we should be setting these devices like this. Well,
Mhm.
next thing you know, they call all these different people out and all these different experts and everything. Next thing you know, I hear them all, oh, we got to go back and fix them all because
Yeah.
I was right. But it was just funny, and I enjoyed, just being right for once. But at the same time, it's like I don't care about really being right. I want everyone to have. I want everyone to excel in the industry.
Hmm.
That's my goal, and
And
I know you have the same goal yourself.
oh yeah, and that's why we spend so much time uh, simplifying things the best we can. And like when you look at this right here, here's 430.24, and this goes back to what I was talking about the feeder a while ago. I said if you're going to a single motor, it's a branch circuit. There's no feeder. I don't care how that definition he tries to twist it the way he wants. This is fact here. And what it says here, uh, several motors on a motor and other loads. And it says here, conductor supplying several motors or a motor or motors and other loads. Okay. So
Right.
that's telling me there's two or more here. All right.
I agree. I
And
agree 100% with
and
that.
and it's not going to a single. Now, when
Yep.
you look at this, it says, and if you look, it says go look at 430.66A, which is what I was talking about the table values. And it says the largest rated motor that's there, you take it 125%. And then in Prin 2, it says all the rest of them are added at 100%. But I'm still going to use the table values to do this calculation. And that's why I
Right.
said start at the front and it's going to come back and tell you what you're doing is correct. All right.
Yeah.
And
And
then
I
look at,
do I do like that interpretation on that, just for the fact, kind of like we go into the definition of individual branch circuit,
mhm.
because individual branch circuit doesn't connect to an outlet.
No, it doesn't.
Why would they need to have a specific definition that does not mention an outlet?
Sure. And
So I'm going to be interested this next cycle because they're trying to go get outlet added to individual branch circuit, and I think that's going to be a tough sell. But,
it's going to be a tough sell for the simple reason is you can have a branch circuit that just supplies an outlet. Just in the definition of branch circuit, it says outlet or outlets. So why do you have to have a definition for an individual branch circuit to utilization equipment if you already have it there for a branch circuit?
right?
I mean,
Because
that makes no sense. But
yeah, go ahead. Sorry to interrupt.
and then if you look, it says in Pren 3, if you have non-continuous non-motor loads, you take it 100%. And if they're continuous non-motor loads, you take them at 125%. And then
Right,
there's another one I'll point out as exception one, because we're going to look at it in a little bit, where I talked about where you had short time, intermittent, periodic, varying type duty motors. It's going to refer you back to 430.22E when you're doing that calculation. Okay.
right.
And I'm going to show you that calculation. It's actually pretty good. All right.
Okay.
Now, if you look here, you'll see in our illustration, we tell you feeder conductors. You're going over to that gutter, and we tell you to look at 430.24 and also 25, and then you feed everything from that point. And if you
Right,
look, I want everybody to see this. This calculation hasn't changed. I'm going to go look. This is three phase. So I'm going to look at table 430.250. And as I said, you just go over here and you pick up your 40, 50, 60 horsepower and put the amperages there. And then whichever's the largest, which is the 60 horsepower, you take at 125%. And then everything else is added at 100%. And whatever that amperage is, go to table 310.16 and go up to the next size conductor in the 75-degree C column. And that's it.
so basically what you're saying is that potentially, so you have your feeder coming from your, let's just say that's an MCC, whatever, coming from your source.
Right.
Then you have your feeder. Then would the everything after that disconnecting means be branch circuit, or would they all still be feeders?
No, those are branch circuits connecting to the feeder conductor.
Gotcha. So that
It
would be like a tap gutter connecting the branch circuits to the feeder, or actually it would be feeder on the line side of that disconnect, right?
Sure, because you're coming over,
Okay.
you're taking your feeder, then you got each one of those calculated separately. Alls we're doing is having a size feeder over there for all three motors that can be running at the same time, with the largest
Gotcha.
taking at 125%.
Oh, okay, I see. So they don't all have to be continuous duty. They could all be different duty cycles, and you're calculating that feeder based on the 125% and 100% and all that. I got
Right.
you.
Yeah.
Okay. So
And
it even
and
goes even down to calculation too.
sure. And alls we're doing at this point, I've already showed you how to do the branch circuit going down there. Alls we're doing is making sure the feeder's large enough for all three motors. And th- and that's what I'm
Gotcha.
saying. That's what a feeder is. It supplies two or more.
I
Okay.
see.
And
Okay.
then
Yeah,
everything
makes
down
sense.
from that point is a branch circuit,
I got you.
which
Okay.
which would be
Yeah.
funny because uh, uh, if I come from up there from, I say that's a feeder, and I come down to that disconnecting means right there,
Hmm.
that is going to be a branch circuit from that point. You see what I'm saying? It's not
Hmm.
going to be a feeder to a branch circuit. That makes no sense.
Yeah.
How you're going to size two feeder conductors at that point is what Ryan was
Right.
saying. That you don't do
Yeah.
that.
Well, and then your tap rules too would kind of dictate some of that sizing. So, like, let's just say you went and added a fourth disconnect, and then you went with like the 10-foot tap rule, then you'd have to go off that whatever that is feeding that uh, MCC or your panel board, and just make sure that you're following those tap rules and going 10% of that primary overcurrent device if you're 10 foot, or 1/3 if you're 25 foot.
That's right. And when you go over and look at that, and you look at your tap rules and everything, and tie that in with 430.28, that's where those tap rules come in. And basically, once you size that feeder and that upstream overcurrent device 10 foot or less, that's going to be divided by 10. If it's over 10 foot, everything else is taken at a third.
Gotcha. Yep.
Okay.
I would agree.
All right. Now, this is one I'm going to look at. Uh, Dealing with uh, my phase conversion here, and this is where you get into A1, A2, depending on if it's a variable load or a fixed load. But we're going to look at doing a calculation on this, and I'm not going to do anything different here. I'm just going to show everybody here. We're doing, in this case, we're going to do a variable load. All right. Now, all I'm going to do is I'm looking at this. I got a three-phase motor. I'm going to go look at table 430.250, pick up my 230 volts, come down for 25 horsepower, get my amperage. And then if I go back here and I look at this variable load, it says to take it at what? 125%. So I'll take it at 125%. And then whatever that amperage is, I'll go look at table 310.16. The next size above that amperage rating is the size THWN conductors you need. Now, the
Right.
thing I like to point out, did you really see any changes in the calculation other than the remaining motors being taken at 100%?
Yeah.
It's
No, it's just largest motor, right?
mhm, it was the same calculation. Everything was at 125% so far, except what? The remaining motors at 100%.
Oh, yeah.
That's
And
it.
we run into this too, just to give all the people watching this context. We argue this nameplate argument a lot, and people are like, "Oh, you're putting number 14 on a 30 amp overcurrent device. You're going to burn places down." Well, what you don't realize is that if you do all this calculation correct, that motor is only going to be running about 15 amps.
Mm-hmm.
Just because it's on a 30 amp overcurrent device doesn't mean anything. So
It's
when
just
you,
there for the starting current startup of the motor because you have that
yeah,
inrush current. That's it.
yeah, and you mentioned that 240.4G, which gives you special permission to add overcurrent, exceed the overcurrent of the conductor. So a lot of people mention the asterisks in 240.4D, and that would be incorrect and incorrect interpretation. The reason why they give you this special permission is that nameplate that's on that motor is going to give you the minimum circuit ampacity, and that's all you have to cover.
Mm-hmm.
And that motor is actually the only thing you're supposed to provide from that panel board or MCC. I don't know. I'm not trying to say your illustration's wrong, James. I'm just saying it's more visual for me from like an MCC standpoint. But when you're coming from that panel board, that source is only required to provide short circuit and ground fault protection. That source is not required to provide overload protection.
No, and the
So
reason it's set up like a pound board is because we only have so much space on
yeah,
the
yeah, and
illustration.
it's fine. There's nothing wrong with it. I was just kind of for a lot of like I have a lot of industrial people that follow us and always ask me, well, is that a paddleboard or MCC? But it doesn't matter either way. It's your source. It's
Right.
people don't understand that you don't need that 30 amp overcurrent device is not required to provide overload protection for the thermally protected motor.
Right. Now, this is good because here's one we're going to look at 43022B, and I'm going to start tying in a few extra ones that people usually don't see these type of calculations. But this is for a multi-speed motor, and basically it just tells you the same thing here. The ampacity of the branch circuit conductors between the controller and the motor shall not be less than 125% of the current rating of the windings that the conductor is energized. Now, the reason I'm bringing that up is because those are the conductors between the controller and motor. But now, if I'm looking at the selection of the branch circuit conductors on the line side of that controller, looky here, it says it shall be based on the highest of the full load current rating shown on what? The motor nameplate, which is what you were just talking about. So if
Yes,
I'm
sir.
doing multi-speed motors here, they're not using 430 points or using the tables. They're using the nameplate because they're telling you to use it.
Right.
Okay. So when I look at this calculation, and this is one that's getting updated right now, but you'll see we're showing you here, we have these multi-speed motors and we're showing you the RPMs for the motors, and then we're showing you what the amps is for it. Okay. Well, naturally, we got at 3420 RPMs is 27 amps, 2280 is 35 amps, and 1710 is 45 amps. And it says when I'm doing the branch circuit conductors, I want to take one of the largest at what? 125%. So
Yeah.
you take 125% of that 45 amps, that's 56.25. The next size
Yep.
above that, and you can see it says table 310.50. It's table 310.16 now. That would be 65 amps, which is the number 6 conductor. So that's the branch circuits coming over to the controller. Then when I get to the multi-speed controller, it said to take each one of those at what? 125%. So I'm going to size each one of those multi-speed motors individually. So you take 27 amps at 125% is 33.75 amps. 35 amps at 125% is 43.75 amps. And 45 amps at 125%, like it was for the branch circuit conductors, is 56.25 amps. Then you go down and look at table 310.16, and it tells you need a number 10, a number 8, and a number 6.
Wow.
That's simple.
Okay.
But
Yeah.
but if you notice, the only difference that changed in this calculation is I still did the largest motor. I just didn't add them at 100%
Right.
because because they're going to operate at different times. And then once I was going to operate each individual one, then from that controller to that multi-speed motor, then you're going to do each one of those conductors individually. But I still did it at 125%.
Yeah, and actually, this is actually not bad because Mark Candles will be happy because you got the 310, 15, B16 in there, and he's still on 17. So
Well, I can tell you those are being updated, and all the colors, panel boards like you were seeing in the previous ones, that
yeah,
these are what they're going to look like.
nice.
All right.
Well,
Now,
I really enjoy it. And one little tidbit, I will be doing a lot more stuff on 2023 moving forward. Like once Colorado adopts 2023, um, I will be doing a lot of my stuff based on 2023. I haven't switched to 2023 yet, just because we're still on 2020. So
okay. Well, now here's another one you don't see much of is where you get into a Y start delta run motor, and it tells you when I'm on the line side of that controller, I still take everything at 125%, but it tells you for 430.6A1, so that means I'm going to use the table value here. Okay. And then
gotcha.
it says then passage of the conductors between the controller motor shall not be less than 72% of the motor full load current rating. And where's that multiplier attained from? That's multiplied in the informational. It shows you is multiplying 58% by 1.25 or 125%. And
Oh
that's getting
yeah.
72%, but it's still you're still in the calculation going to use the 58% because I'm going to use the 125%, which is makes it 72%.
Yeah, I
Yep.
remember that. That was one of our controversial ones in the death match we ran
Yeah.
into.
So looky here. I'm gonna show this. This is very simple. So I'm looking at that motor, and and we're telling you here it's a three-phase motor. We're just giving you all the information here. We're telling you it's 52 amps. Okay. So if I'm doing the branch circuit, I take it at what? 125%.
Yep.
Done. Doesn't get much easier than that. Then we tell you here, we say, all right, now if you're doing between the uh, the uh, uh, the conductors between the controller and motor, you're going to take that 52 amps, but I'm going to take it at 58% time 125%, and that's going to give you 37.7 amps. And then you just go to step two based on those amperages. There's your size conductors. And
Right.
that's what I'm saying. If you notice, I still had the 125%, but since this was a Y start and a delta run motor, I had to take it at 58%. And that 58% times the 125% is where you got the 72%.
Gotcha. Okay. So
Okay.
would it work both ways if you did it both ways? Like if you went and you just instead of taking it at 58%, just took it at 72%,
Yeah,
because
you
it's
get the
already
same thing.
calculated in.
Yeah,
Yeah.
you get
Okay.
the same thing. Yeah.
All right. Yeah, that makes sense. So either way, it's like apples, oranges,
And,
whatever.
and
Tomato, tomato.
this is an easy one. Part winding motors on the line side of that controller, I still take it at what? 125%, and it tells me to use 430.6A1, which is going to be the table values. And then it says between the controller and motor, it shall not be less than 62.5. Well, since it's part winding, that means half. So I'd take the 125% times 50%, and that's where you get the 62.5%.
Gotcha.
Okay. So here's the same calculation. I'm going to come in here. I look at table 43250, and it tells me that 40 horsepower, 230-volt three phase, I need 104 amps. Take the branch circuit conductors at 125%, and that's going to give you what? A number one, which is good for
Right.
130 amps. Now, if I'm going to do from the controllers to the motor, guess what? It would be half of that.
Right.
That's how simple It really is to do. So it would just be 65 amps, which would be a number 6 conductor.
Yes, sir.
Okay. Now,
Yeah, you're going off the 75-degree
yeah,
cable,
75. Yeah.
dude. So there is some controversy on that. Just to like shout out to everyone who always brings this up. If you're like in a testing situation and the terminals are unknown, then you have to go off of 110, 14,
C1A and B.
C1, A and B, and go off the 60-degree column. I doubt you're like, there's people showing me terminals from the 60s
Sure.
that were 75 degree C rated. So I
Yeah.
doubt you're going to find any that are not 75.
It'll be a much older motor if you're going to run into a 60.
Yes, sir. I agree. I just wanted to throw that out there for guys that just so they understand, don't get confused.
All right. Now, this one is other than continuous duty, and this is where you have short time, intermediate, periodic, and varying duty type motors. And it tells you to have an ampacity not less than the percentages. And this is based on what? The nameplate current. Okay.
Yep.
So I'm going to use the nameplate current, and then it tells me to use the percentages that are in table 430.22E. So if I look at this table, depending on what the rating of the motor is, let's just say that I had a periodic motor that was 15-minute rated. You're at 90%. If it was a 5 rated motor and is, say, intermittent, then it's 85%. Okay, so
Right.
this is where you're going to pick up the different type of percentages based on the type of motor. So when
Right.
I look at this motor, and I've got a 100 horsepower intermediate 15-minute duty. So and I'm just going to go back and look at the table. It's 15-minute rated and it's intermittent. So here's 15, come down, pick up intermittent, tells you it's good at what? 85%. Okay. So if I come over here and I take a 100 horsepower motor, that's 460 volt three phase rated at 124 amps. You go to table 430.22E, take that at 85%. That's going to give you 105.4 amps. And the next size above that's 115 amps, which is a number 2 conductor. And that's how you size for duty cycle type motors.
All right. And
Okay.
we had a question come in, really weird question came in. What's a motor?
Yeah. I wonder where that came from.
That was so funny. That was on NEC Live.
I got to talking too fast.
So funny.
My,
No, dude, that's awesome, man. Dude, I love your content, sir. It's really awesome, and just like you just keep bringing the heat, you just keep elevating every time. I really appreciate you putting the illustrations in, even the ones that are not updated yet, but everyone could see the difference. I think you could see the contrast. Like even your 2017 ones are even still good.
Yeah, the new
So,
ones are really going to blow it away. And I'll say this: you can go look at a lot of these other publications. Some of that stuff I was showing you ain't going to see that in other publications, and they don't go that in depth. And I'll tell you this: when you go into our generator transform motor compressor book, we go very in depth on all those calculations. And I always try to teach it from the easiest standpoint possible. And what I like to point out about all them calculations, pretty much everything was at 125%. And the only time you really worried about it was where you got that Y start delta connected top motor. You had the 58% and a part winding motors at 50%. And then when you got to varying duty, you just need to look at table 430.22E for the different percentages. Other than that, everything was 125%. So
well,
it shouldn't be
and
that
you
hard to understand it.
yeah, and you saw the one that I did for the minimum, like because I got a lot of people fired up because the minimum is 115%.
That's for the disconnecting means.
Right. But
Yeah.
yeah, like I say, it was interesting because like I say, that was one part that isn't 125%. It caught people off guard, you know.
Sure, it does. And that's just needing to know your different sections. We actually show you that calculation and looking at 430.110A to apply that 115%. And we go through all that. And basically, all it's telling you is, is that's the minimum for that, but your size in the conductor is 125%. So it's going to be large enough anyway. But, you know,
Right,
the thing is to show you in the code the percentages, so if you were taking a test and they ask you how to calculate for that disconnecting, means you know it's 115% is the minimum.
right. And